Okay. So this is Escalate. I'm using a virtual machine that's running in like just my Firefox web browser here. I'm going to switch to full screen so there's a little bit more screen real estate. So this is all a virtual machine that's not running on my computer. It's just you can access it right through Escalate. We were talking about exploitation. This is the first Linux exploitation challenge that we have in the system here. If I hit the play button, it's going to go off and it's going to clone a VM so that I can go attack that VM. And it's also going to give me a set of artifacts to download in a second.
So is that like how it works? Like the best cybersecurity professional is somebody who could attack your computer themselves?
Yeah, in my opinion, the tippity tip of the spear kind of thing is the people that build these capabilities, not the ones that necessarily use them. That's just kind of my nerd pride. Like, you know, I'm sure that the people that use them feel the other way, right? It's just one of those things. But I'm a big believer that the people that build the new capabilities, that's a really hard thing to do, and it's not talked a whole lot about in the public. So we have a new Bobcat Congo machine here. This is the IP address that we'll attack, and this IP address is just for this VM, right? It's not like a real one somewhere on the internet. It's on our VM here. So I can go, I should be able to ping it. Almost like we can ping it. So I'm just testing if it's up. The artifacts here, this is the stuff that the challenge generated for us. And if we read it, what we'll find is, if we read like the challenge description here, the program is going to listen on a port, and we'll be able to attack the program. So I'm just going to go unzip that file. Okay. WebVM has some problems sometimes. I apologize. Oh my gosh, that's going to be super annoying. I'll just learn to avoid that. Okay, so in here, I unzipped the thing we downloaded from Escalate, and we get two files back. We get a program, and this program is running on the VM that Escalate stood up for us. And then it has some configuration file here. So if I read the configuration file, what this tells us is that this program is going to be running on this port, 1378. So at this point, we can go try to connect to that port if we want. We have this 1378. If I connect to it, we see some text. Cool. From a security researcher standpoint, right now, I would want to now figure out, this text came out, it has some effect. What do I do now, right? I can do that in kind of two ways. I can reverse engineer the software using something like Ghidra, if you want, or Binary Ninja, or there's a bunch of tools for reverse engineering it. I could also just play the game because I know that it's meant to be like a simple challenge on a website, and we might be able to just kind of figure it out. So I'll ask you, man, which way do you want me to solve it? Do you want me to reverse it, or do you want me to just kind of play the game and hammer a solution out?
I guess what would be a beginner's like most obvious way to doing it? Like obviously reverse engineering it because like that tech tool seems cool, but I guess when somebody is going through Escalate, they would most likely be using like playing the game.
Yeah.
Yeah. So let's do it that way. So like somebody who wants to use Escalate gets a more concrete idea of like, okay, this is how you start before you even get into those tools.
Yeah, absolutely. We can do that. And in reality, people will use these two approaches together, right? And so we can maybe highlight that too.
Okay, yeah, that works.
So the game, it's asking you to like choose a direction, right? So do you want to go east, west, or north? So since I would be attacking this, I'm sure that those directions work. as an attacker, what I want to do is try the things that were maybe not like thought of or tried from the developer's perspective, right? So they're expecting a letter, so I might try like a number. Okay, well that's not a valid choice. Great, right? If I try it again, if I run it again, can I just hit nothing? Will that work? And I'll try these various things to see if I can break the program in kind of a unique way. If I do get a break in the program, then I could go reverse engineer it like we talked about and find how we broke it. So if we just try some of the directions, okay, it advances the story that door's locked. So let's try another direction. Okay, the game kills us. Cool. We found a key, and we're just kind of playing through the game, right? We know that north has a locked door. Okay, so at this point it asks us, give the thing a name. What kind of name would you want to give it? I'll let you kind of try here for a second.
Maybe a name with all numbers, like 000.
Maybe, zero. Sorry, I wasn't fast. Let me try again. A bunch of zeros, what you said?
Yeah.
Okay, yeah. Hey, you did it. There's your flag. So from Escalate's perspective, we would go copy this, paste it over here, and we complete the challenge. The question you might have, of course, is, I did it, but what did I do? Right?
I mean, I'm assuming it was like based off what you were saying with like send a bunch of A's to something to sort of overload it. So I assumed it was that.
Yeah, you 100% got it, man. That's exactly it. Since that was kind of fast, if you want, I can open it in Ghidra and I can show you what the actual vulnerability is and why that worked.
Yeah.
Okay. So this would be kind of the other way to solve it, right? Yeah. So in Ghidra, we're just creating a new project, and I'll add the program to the project. It'll ask us what kind of program it is, and in general, Ghidra is really smart, and it'll give you all the right answers.
And is Ghidra like a open source tool? Like, is this something that anybody can just download?
Absolutely, yeah. Actually, the National Security Agency put this out and made it available for everybody on GitHub a couple of years ago. And yeah, it's a great tool. It's just a phenomenal tool. It has a lot of functionality in it. And it's totally free and made by the USG, so that's pretty cool. So
can you talk a bit about like what was the incentive for that? Like, why would they? Because I feel like in my mind, not really knowing about, I guess, tech so much, it'd be like, wouldn't I want as a government for people to not have the tool to reverse engineer?
Honestly, I don't know. I don't know what the motivation would be. If I were to purely speculate, right, it was just pure speculation. I have really no idea. I would imagine it's because it's a cool piece of technology, and the developers that worked on it are proud of it, and they want people to see the cool thing they worked on. And I know it's sort of fun to kind of dump on the government, but I think in general, people that work there do just a phenomenal job. And obviously, I'm biased, right? But yeah, I think that they're probably just proud of the work they did because it's really an amazing tool.
How long did you work for the NSA?
For just a couple of years, not long, like a million years ago. So what I'm going to do is I'm going to try to find. I'm a little rusty with Ghidra also. Since we ran the program, we see some strings, right? Some like messages that it prints out. What I want to do is find those messages in the program and then find the code that uses those messages. So in particular, we see something here about a magic sword. If I go to these defined strings, I can type like magic and like, oh, there's the message, right? Merlin's beard, whatever. In Ghidra, we can see that there's cross-references to that, which is the cross-references are the places in the program that use that string. So if I double-click at treasure, this is what the code looks like. So if you've heard like assembly code, this is the assembly code on the left, and then on the right is Ghidra's decompiled version of that. So this is closer to what the developer would have written when they wrote the program. So what we see is get treasure gets called. It prints a couple messages. It reads our response into a buffer called local 16. And then it returns. So there is a vulnerability in here already, and it's all surrounding this read function. So read takes 3 arguments that we see here. This is where the computer science stuff comes into play, right? You're looking at like C code here, basically. And so what you learn in those computer science like operating systems classes is that the read function, the read system call, takes 3 arguments. The first one's where you want to read from. The second one's the buffer that you're going to read into. And the last one's how much you want to read, right? In this case, we're going to read from the keyboard standard in. We're going to read it into some buffer that Ghidra calls local 16, and we're going to read it for 100 bytes. The vulnerability is that we've only allocated less than 100 bytes in the program. And we can calculate exactly how much it is, but it's less than 100. That's kind of what that 16 is indicating. And so if we put more than 16, the program's going to crash. So sure enough, if we go back here and count, this looks way more than 16, right?
Yeah.
That was kind of a quick explanation to that. It all kind of makes sense. So.
And from, I guess, a dev's perspective, of somebody who was coding this, like, why wouldn't they make it 100? Or like, is this something that like, okay, it was a minor mistake that they didn't think about when they were doing the code too quick? Or like, I guess, how do you, like, are these just things that just like, just happens?
It's typically something that was just overlooked, right? It was just a mistake on the developer's part. It's rare that you'll see a bug like this that's like this explicit nowadays, but it still happens. And every time that you see something like this, the fix is trivial, right? Like, okay, we'll just either increase the size of the buffer or we'll decrease the amount that we're reading. Easy fix. But knowing that is the hard part, right? And so that's the part that security researchers will spend a lot of time trying to find is where did the developer kind of mess up.